problem, Pacific Atlantic water flow. Let's try to read this problem. There is a M cross N rectangular island that borders both the Pacific Ocean and Atlantic Ocean. The Pacific Ocean touches the island's left and top edges, and the Atlantic Ocean touches the island's right and bottom edges. So basically, it says that there is a island of M cross N matrix, and its left and top on its left and top there is a Pacific Ocean, and its bottom and right there is a Atlantic Ocean. Now it says that the island is partitioned into the grid of square cells. Now it is partitioned into the square cells, and you are given M cross N integer matrix heights, where heights R C represents the height above sea level of a cell at coordinate RC. So basically the values of this, basically they are trying to say the values of these cells represent the height above sea level. So it means that this is, let's say if the unit is meter, then this island is at 1 is 1 meter above sea level. This island is above 2 meter above sea level. Similarly, this island is above 5 meter, is 5 meter above sea level, and so on. So it says that the island receives a lot of rain, and the rainwater can flow to the neighboring cells directly north, south, east, and west. If the neighboring cell's height is less than or equal to current cell's height, water can flow from any cell adjacent to ocean into the ocean. Into water flow from any cell adjacent to an ocean into the ocean. Okay, so it is saying that all these islands receives a lot of rainfall, and any any other island which is at lower altitude will the water can flow from higher altitude to lower altitude. Basically what they mean to say that, so this is at a higher level, and if the rain happens on this cell, then water can flow from this cell, this cell, this cell, and this cell as well. And also they are saying that these are the edges from where the water can flow to Pacific Ocean or Atlantic Ocean as well. So finally, they are saying that return a 2D list of coordinates where result I is equal to Ra, Ci denotes the water can flow from cell to both the Pacific and Atlantic Oceans. Basically, they are asking that find all the islands from where if the rain happens, then the water can flow to both the Pacific Ocean and Atlantic Ocean. For example, let's see this border island. This border island, if the rain happens on this island, the water can float into Pacific Ocean and Atlantic Ocean. Similarly, for this, the water can flow from Pacific Ocean to and as well as Atlantic Ocean. So what is the brute force way? The brute force way, or the general way, which comes the first that comes to our mind, that for each cell we will do a BFS or DFS. We can do a DFS and find whether there is a path from here to Atlantic Ocean or not, right? Similarly, what we can do a DFS, find a path such that there is a we can reach Pacific Ocean and Atlantic Ocean or not. So basically, you need to check from here, can you reach any of these edges, or can you reach any of these edges, and as well as these edges. If from here, if you are able to reach any of these edges, or any and as well as any of these edges, then the water, if the rainfall happens, if the rain happens on this island, you can get the what then you can include this cell as an answer, the coordinate of this cell as an answer. So you have to find all such coordinates. So that would be like order of n cube, right? Because you have to do a BFS, DFS, and then for each cell you have to do. So how can we optimize it? Let's see how we can optimize this. As from the Leetcode problem itself. Okay, and I have also drawn two matrices for Pacific Ocean perspective and Atlantic Ocean perspective, that what are the edges which are flowing from to Pacific Ocean, and what are the edges which are flowing to Atlantic Ocean. So basically these are the edges which are flowing to the Pacific Ocean, and these are the edges which are flowing to the Atlantic Ocean. And also mind that this cell and this cell, if the water falls in these two cells, then water can flow to both Pacific Ocean and Atlantic Ocean, and similarly here Pacific Ocean and Atlantic Ocean as well, right? So you can mark these two cells. Okay, just for marking, I'm just saying that from these two cells. Now let's think from Pacific Ocean perspective. Let's consider this cell. Okay, so if we are able to find from what are the cells from where it can get water from, right? Like this can get water from here, this can get water from here, and so on, right? Similarly, what are the cells it can get water from here? So this can get water from here, this can get water from here, this can get water from here, and so on. So this is from Pacific Ocean perspective. Let's see from Atlantic Ocean perspective. If we are able to see, if we are able to find what are all the cells from where these edges can receive water, right? These edges can receive water from any of these islands, right? And these edges also got water, and these edges also got water to Pacific Ocean. Then we can say that this is one of the cells which can give water to both the Pacific Ocean and Atlantic Ocean. Let me try to explain this. That let's say this cell is getting water from two. For simplicity and understanding perspective, let's keep it simple, let's not draw this. From similarly, this cell can get water from this cell can get water from this, but this cell, the water cannot flow from this to this cell, right? Similarly, the water can flow from this cell to this, right? This this was only from Pacific Ocean perspective. Let's consider the one of the cell of this Atlantic Ocean. The water can flow from here, okay, right? The water, right? Now let's try to mark this. So if we are looking from Pacific Ocean perspective, we will mark here one, we will mark here one, we will mark here one, right? And if we are looking from Atlantic Ocean perspective, we will mark here one, okay. Now just at this moment, just see that what are the cells common to these two matrices, right? This one, right? This cell is common, right? And also we can see that the water, if the water is falling on this island, it is flowing from here to here, and from here to Atlantic Ocean. And also the water is flowing from 7 to 4, 4 to 2, 2 to 2, and from Pacific Ocean, right? So we can say that this is one of the cells from where the water can go to Pacific Ocean and Atlantic Ocean. So what we can do, we can try to find out for each of these edge cells from the Pacific Ocean perspective from where it can get water, and similarly from Atlantic Ocean perspective we can try to get water from what are the possible islands from where it can get water, right? So say, let's say for example you get some picture like this, okay, you get some picture like this, and you get some picture like this, okay, after doing all the iterations. So after doing all the iterations, so basically your answer will consist of these four cells. That's it. Let me try to code, and then we will see that. Similarly, column is equal to, now we will create a visited matrix for both Pacific Ocean and Atlantic Ocean. Let's call it PO visited, Pacific Ocean visited, new of C. Similarly, for Atlantic Ocean visited, we will be doing BFS, okay. So we will create a queue integer array, and let's call it Atlantic Ocean Q, Pacific Ocean Q is equal to English, then Q Atlantic Ocean Q is equal to new English. Okay. Now we will try to add these edges to the Pacific Ocean and the Atlantic Ocean Q. So let's try to move along Pacific Ocean first in columns. Int I is equal to 0, I less than column I plus. If you sorry here, if you see here, it is 0 0, it is 1 0 0 1, sorry, 0 2 0 3 0 4. So this will go to Pacific Ocean, and if you see here, it is in column minus row minus 1, right? Row minus 1, let's say here it is 5 rows, so it will be 0 1 2 3 4 4 0 4 1 4 2 4 3 4 4. So this will go to Pacific Ocean, this will go to Atlantic Ocean. Okay, so what we will do, Pacific Ocean Q dot and new int 0 comma 0 0 comma 1, so it will be 0 comma I, right? 0 comma 0 0 comma 1 0 comma 2, so I will be variable, and at the same time what we will do, we will mark these cells as visited as well. 0 comma I equal to 1. Similarly, for Atlantic Ocean Q, we will add AO Q dot add new int, right? It will be row minus 1, right? This is 0th row, first row, second row, third row, fourth row, right? So this will be R minus 1 comma I. Sorry, R minus, yes. And at the same time, what we will do, we will make this as well, R minus 1 comma I is equal to 1, right? Now we will try to move along this, uh, right? Okay. For int I is equal to 0, I should be less than row, right? I plus plus. So just think that this 0 comma 0 has already been added to Pacific Ocean here already, so we don't need to add that. So we can write that if I is not equal to 0, then only you q dot add new int, right? And if you just think 0, this is 0 0, this is 1 0, this is 2 0, this is 3 0, this is 4 0. So this I is varying, right? So this would be the, and at the same time we will mark this visited as well. Okay. Sorry. Right. I comma 0. Also, just see that uh, this if we are moving along this if we are moving along this column, then this has already been added to Atlantic Ocean, right? So again we do not need to add this, so we will write this condition as well. If I is not equal to 1, then just copy paste this, and this is the C. This is zero row but fourth column. So 0 comma 4, 1 comma 4, 2 comma 4, 3 comma 4, 4 comma 4. So what is happening here? This will be column minus 1, right? And this will be 0. Similarly, this will be column minus 1, and this will be, sorry, I, right? Not 0. Okay. So everything is right, correct? 0 I, r minus 1 I, r minus 1 I0, I comma c minus 1, I comma c minus 1. Okay. In this way, what we have done, we have added all the edges to the cube. Okay. Now we will try to do a BFS. Let's try to write that code as well. For that, let's write here void BFS, which takes this integer array heights. Okay. Also, what we will do, for simplicity, we will define as a global variable so that we can access in that method as well instead of passing as a parameter, right? And then I will take q also as a parameter. Okay, let's call it q, and we will also take a visited array matrix for marking what are the cells reachable from these edges. Okay, from Pacific Ocean or Atlantic Ocean. Now what we can do, while q is not empty, right? Q dot is empty. First of all, we will try to poll the current element of the queue. Sorry. Okay. And let's say int x coordinate as a 0 and y coordinate as a 1, just for simplicity. Okay. Now what we will do, we will also define the directions here. X direction is equal to 0 comma 0 comma 1 comma minus 1, and similarly int y direction equal to 1 comma minus 1 comma 0 comma 0. Okay. Okay. Now here we will try to go through all the adjacent cells. Int I is equal to 0, I less than 4, sorry, I less than I plus plus. Okay, now we will try to get the new coordinates, which is equal to x plus xd I. Similarly, int ny is equal to y plus yd ka I. Okay. Now this is now we need to check, right? We need to validate it, right? How we can validate that whether this is a reachable point or not? If nx should be greater than or equal to 0 and nx is should be less than r. Similarly, new y should be greater than equal to 0 and ny should be less than equal to less than r, and this visited should be visited का nx ny should also be equal to 0. Also, what I am trying to say that the neighboring cell height should be greater, then only the water can flow to this cell, right? So heights heights of nx, sorry, ny should be greater than equal to heights of xy, right? Heights of xy. Then what we can do, we can add it to the q, right? Q dot add new int array nx comma ny, right? And at the same time we have to mark this as visited as well. Visited nx comma ny is equal to 1. That's it, I think, for BFS, right? Now let's try to call these two. While everything is fine, right? Seems to be okay. Okay. Now let's try to call BFS. First of all, we will be calling this. We can call anyone first. So let's try using Pacific Ocean. So it is taking heights first, then Pacific Ocean Q, and then Pacific Ocean visited, right? Similarly, BFS of heights, comma Pacific Ocean, Atlantic Ocean Q, and Atlantic Ocean visited, right? Now we will try to get the common, right? As we have told earlier, we will try to get the common cells from where the water is flowing to in both the directions. For int I is equal to 0, I less than 0, I plus plus, we will just copy paste this, right? Here we will change C, here we will change to J, and then here also J, here also J, right? And then we will check, right? So it is already right, correct. If PO visited I comma ij is equal to 1 and Atlantic Ocean visited ij is equal to 1, then what we need to do? Now we need to create a return result array, right? Result is equal to new array list, right? Similarly, what we can do, list of integer is equal, let's say coordinates CORD is equal to new array list. Okay, now let's add these coordinates. CORD dot add I, let's copy paste this, add J, then let's add this to the result dot add chord. Okay, and finally we will return this result, right? Return result. Let's try to run this if we have any compiler error. Okay, we are getting wrong answer. Where did we mess up? We have done the mistake. Okay, one mistake is here. It should be I should not be equal to r minus 1. Okay, another mistake, it should be Atlantic Ocean Q. Okay, this Atlantic Ocean mistake. So basically we have done the mistake, copy paste mistake. Let's try to run again. Okay, again I think I messed up. It should be A. Okay, now let's try to run again. Okay, now you can see it is running fine. Let's try to submit this. See, I have also submitted earlier as well. Okay, so you can see that we got something. Okay, we got the result. Yeah, that's all for today. Thanks.